Okay. What's that mean? A little bit of explication. That's a one-digit slice of Babbage's difference engine number 2 and the code that corresponds to it. So I'm Mike Albaugh, and I'm here to talk about emulation in the sense of a computer emulating some other, usually computer system. And I'm about the same age as the stored program electronic digital computer. Yeah. So I spent a lot of time at the Computer History Museum in Mountain View, mostly as a volunteer, not an artifact. So while I was doing that one day, someone asked me, could the Analytical Engine emulate the difference engine? Now, that wasn't completely out of the blue, because I'd been demonstrating the difference engine, and I'd written an Analytical Engine emulator for the IBM 1401 that the museum had to celebrate Ada Byron, Ada Lovelace, whatever. Read some Regency novels. Everyone has 5 different names. Her 200th birthday. So these are very different machines. So the difference engine there is basically a stack of adding machines hooked to a typesetter. And its job was to produce mathematical tables by doing successive values of 7th order polynomials approximating whatever function you wanted. And the Analytical Engine was much more complex, more ambitious, and in many ways a precursor to the modern digital computer. Although supposedly Konrad Zuse, who actually built a mechanical computer in 1936, had never heard of Babbage. But so it was in the hope of demonstrating the first documented computer program by Ada that I had decided to use the 1401 because I had it laying around. So I went a little overboard. And so I emulated the difference engine on the Analytical Engine, on an IBM 1401, on an old Mac laptop, on a slightly newer Mac laptop. And that was mostly with code that I had just laying around, and which led me to ask, why do I have that laying around? So, because I'm a hoarder. Including software, and because that compresses a lot better than motorcycles. And I've been doing emulation for quite a while. My first relatively large program, after an intro to computer programming class, one class, I decided to emulate the IBM 1401 on an IBM 1130. So the 1401 is an interesting machine. It's my third computer I ever met, and it's the elder brother of the first computer I ever met. And it is almost, but not quite, totally unlike any computer you can think of today. And it's also interesting because it was cheap, reliable, had great print quality. By the way, cheap, $2,500 a month rental. For the base unit you see there, the totally tricked out ones we have at the Computer History Museum were probably more like $16,000 a month rental. And those prices relate that to you could buy a single family home in Sunnyvale for about 25 grand. Anyway, the 1130 was my first binary fixed word length machine. And having met both of those in close proximity gave me a real appreciation for how different computers can be from each other. There's a lot less heterogeneity among computers these days. Anyway, so that emulation project was never finished, and I lost that deck long ago. But I've done a lot of other emulators since. So that stack was actually more of a heap. And I'm going to visit 3 of these in this talk, starting toward the bottom. So one reason we emulate is it's a business case. It's purely business. You just got a new computer. You've got some old software you're depending on. Oh my God, what am I going to do? Well, nowadays you just keep the old computer. But I mean, back in the day of $16,000, you didn't do that. So, and Apple did something similar when they moved from PowerPC to Intel. They let you briefly run PowerPC programs on Intel Macs. And a lot of other people did that long before. So for instance, the 1401. IBM, when they introduced their 360, they said, oh, well, we'll let you, for a fee, emulate your 1401 code on it. And that was enough to get people who might have considered going to some other vendor, of which we will not mention, right? This can be carried too far. I got a panicky phone call in 2000 from a guy because the latest release of IBM's OS for their 360 successor, 4381, had dropped IBM 1401 emulation. 28 years after the last 1401. Okay, so there's other reasons to emulate. I assume at least some of you have run a game on your computer or phone or whatever. The other thing is to get insight into old computers and to study their designs, help understand what their users were doing and what their designers were thinking of. A friend of mine calls this computational necromancy. And the sane people of you will pay no attention to the orange side. It is a rabbit hole too far. Okay, so even if the older machine exists, it can be easier to use an emulator to prepare stuff for running on it. So instead of chilling with 2/3 of the IBM 1401s, running IBM 1401s in the world, I can code in the comfort of my own basement using a keyboard that has a delete key. So, and that's time travel in comfort. But we can also travel forward to emulate a system that doesn't exist yet or may never exist, right? So Lynn Conway and Carver Mead wrote this book, Intro to VLSI Systems, and inspired a lot of people in the world, including a bunch of us at Atari, to design several chips. And we dreamed up a 32-bit RISC processor called the Atari Simplified Architecture Processor. That one got us to seek professional help in building it. So I wrote an ASAP emulator to evaluate design trade-offs and retarget GCC. And Jim Coker, the logic designer in Mississippi, also wrote a different emulator, and we traded test cases. And some of the discrepancies were bugs in either the test case or the emulator. Some of them were real ambiguities in the spec. And it helps. You know, it takes time and money to spin a chip. And if you have to ask how much, you can't afford it. So we did have a few mistakes in the first, but surprisingly few. And I was able to lie to GCC to get around that. And it worked out really well. And to give you an example of how important that can be. So when I was trying to get Ada's program running on my emulation, I had some issues, and I asked Tim Robinson, our local expert, about it. He says, oh yeah, Ada ran across that. And pointed me at some documentation about that, and it occurred to me that if they'd had an emulator, she could have showed Babbage what she felt was wrong and how to fix it, and instead of just blowing her off, they might have fixed it. So unfortunately, there's this chicken and egg situation. It's a lot easier to build a computer when you already have one, right? So just to shout out to some of the people there, Sydney Padua was a big source of information to me. Everybody should go buy Her Thrilling Adventures of Lovelace and Babbage. And Tim Robinson, a master of mechanical computing, was our expert. And that's it. Thanks, everyone.